All right. So let's get cooking. Are we on? Yeah. Okay. How did the assignment go? Working with structs. Not too bad. Um, okay. So let's take a look at that real quick, and then we'll start talking about objects. Um, do we have a preference? What's our preference? Do you want to start talking about objects in C++, then transfer over to Java, or do you just want to jump right to Java? There isn't a substantially difference other than a little bit more pointer stuff. But I'm not sure it necessarily matters. You want to just go to Java?
What do you think we should do?
Well, I mean, we can drop down to assembly. Just go the other direction. I think getting into Java sooner rather than later probably would open up some more competencies for you, maybe make you feel like you could be a little bit more productive in like some of the hackathons and things like that. Although, how many of you went to the Arduino thing the other night? None of you? Remember we had the two guys come in and announce it? All right, so I really encourage you to start taking advantage of some of the things we have in the department. They get announced on Slack and things like that. So right across the hall, the CS Club had an Arduino night, which are programmable controller boards. So, basically it's a little piece of hardware that you connect to a computer and you write the code in C. And you basically are turning off pins, the power to pins on and off, and then you have wires and stuff coming out of there where you can build your own kind of robotic-y things and something like that. So that kind of opens the door for you to do some I don't know, mad scientist-y type projects. So like for instance, like right now I decided I don't want to tie my shoelaces anymore. So I've 3D printed this thing that goes over the top of your shoe and kind of hooks on. And then there's a stepper motor on it. I had to find out what the smallest stepper motor I could get that had enough torque. So it's a, yeah, maybe it's a size of a, I don't know, like a gumball, something like that, maybe something like that. And it sits on there and then it's hooked to wires. And you can tune it how tight you want your shoe on each lace eye perspective and then save it. So when you take your shoe off, you use an app to control it. I'm working on the app right now, but you release your shoe so it opens all the way up. You get your foot onto it, then you just push your memory button and it tightens each individual eye to your specification that you wanted. Just like, like memory seats in a car. That's all done with Arduinos and just a couple of components. That's probably, I don't know, 30 bucks in parts. So take advantage of some of those things. I don't know what they actually did at the Arduino thing, but it would have introduced you to the hardware and the software. It's something that geeks can now take advantage of. You probably saw some of this if you've seen some of the previous Spider-Man series where that guy was more of the tech version of Spider-Man, where he had a lot of, he built his own technology stuff for his webs and he had his, alarms on his doors and all that stuff. That's all programmable controller board stuff. Okay. And I know we had a hackathon the other day, and I know a couple of you did go to the hackathon. Remember today after class, we have a computer science get together right across the hall. So I think 11:30 to 12:30 or 11:45 to 12:45, something like that. I think they're bringing in, I don't know if it's Jimmy John's or whatever, but they do a, kind of a quiz thing for computer science knowledge stuff and give out pretty good prizes. I don't know what the prizes are this year, but in the past we've given out like iPads and like for the top prize, then it gets down to like old Chuck Norris DVDs. It really drops off. We've given out some pretty good stuff. All right, so let's get into the homework. Get this up here. Actually, I'll hide it. All right, what were we supposed to do? All right, so we're supposed to write the code needed to add. So we have two fractions. We have a struct fraction F1, struct at fraction F2. We wrote the struct last time, so we introduced the idea of kind of a new container type. Before we just had to have a whole bunch of variables, individual variables. Then we upgraded to arrays where we can store. Now, keep in mind, we didn't really look at full uses of arrays. We're actually going to be doing something you'll hate me for relatively soon called merge sort. But the good news is you'll hate me even more next semester when we do multi-threaded merge sort. But in any case, we've only looked at kind of taking this collection type and array and kind of bending it to our will to store, only creating 2-bucket arrays and storing like a couple of values in there for the numerator and the denominator. So we kind of introduced that tool, but typically we might store a whole bunch of data points inside of an array and then like maybe sort it, that kind of stuff. So we're not done with arrays. We're going to come back. We'll loop back on them when we get over to Java, I guess. And then we decided, okay, well, this array solution for storing fractions was reasonable enough. It allowed us to accomplish what we wanted to accomplish. But we do have that issue of we as the programmer had to remember that we were putting the numerator at bucket 0 and the denominator at bucket 1. So we look at kind of the next quote upgrade to that, this idea of a struct. How many of you have ever coded in Python before? All right. So in Python, they're not called structs. What is this type of thing called in Python? It's also called this in a lot of other languages. I'm just using Python as an example because it's a very common coding practice in Python. Something called a dictionary. So Python has this idea of a dictionary, which kind of works like an array, but it's a bunch of name value pairs. So you can say, here's my array, give me the value of the array at bucket numerator or at bucket denominator instead of bucket 0, bucket 1, bucket 2. You can name your buckets in a dictionary in it. You can store different kinds of values and that kind of stuff. So a struct is kind of like that, where we have this single variable type that can hold multiple values that we're able to label. And those values don't all have to have the same type. We can have 2 strings and an int or whatever. We can put arrays in there. Structs start bumping up against the wall that we'll talk about more today when we start wanting to also house functions in there. So effectively, when we start to, we're going down an evolutionary path towards objects, towards creating classes. And each time we start saying, okay, we just hit a wall. What's the next invention to get us over to that wall? Well, we looked at arrays to get us over the wall of only being able to store a single value at a time. Then we said, okay, the problem with arrays is we really have, in certain situations, no way of specifically labeling what data we're storing. So they work great if we're just saying, here's a whole bunch of numbers, sort them or give us the average or whatever, where we don't need to identify individual values. But if we need to identify individual values, we saw that arrays come up a little short. So we're probably going to have to rely on our memory or good commenting, good documentation in our code. Now we bumped into structs. Structs give us some more power. We can kind of define our own variable types, right? And they can hold multiple values with names. And it's like, okay, well, this starts making more sense. But I mentioned near the end of last class that Java views structs and classes as equivalents, but they're not. And I'll talk more about that when we get to it. But at least for right now, what we want to see is a weakness of structs. So for example, with a fraction, if I have a fraction that's already storing a numerator and a denominator, we might want fractions to have the ability to reduce themselves. We might want to point at a fraction and say, F1, reduce yourself. And it'll update the numerator and denominator to be the reduced version of that fraction. Structs do not allow us to have functions inside of them. They only allow us to hold name value pairs, individual variables. You can put an array inside of a struct and it can hold a collection of stuff, but we can't hold behaviors, abilities, functions, subroutines, whatever you want to call them. Okay, those won't fit inside of a struct. So as soon as we want our stored values, like a fraction, to start doing extra stuff, structs start hitting their limitations. I also mentioned last time, and I'll kind of show it to you by an example today, that by default, structs are passed by value, not address. Which does make a difference on whether we change a value and send it back out and that kind of stuff. But we at least know that we can work with pointers to structs and bypass that, but just understand the default behavior of it. Whereas if you are a Python developer, or I think most languages that have dictionaries, which a dictionary is a struct, it just feels a little cleaner to write it, but it's the same crap. Dictionaries by default are passed by address. And that becomes an important thing when you start differentiating different languages. Because when you sit down, I've mentioned that all programming languages are effectively the same, right? Learning to program is a skill set. The language doesn't actually matter. And as soon as we start jumping to other languages, you're going to see that pretty quick. You know, we're going to modify what our code here to be Java, and you're going to see real quick that it's mostly the same code. All right. But certain languages have these little idiosyncrasies that do change your problem solving approach with it in terms of default behavior and things like that. Okay, so let's come down here. So we're going to write the code needed to add F1 and F2, storing the results in a new struct. All right, so we know we're going to need a struct for like our answer, right? So we'll say struct fraction answer. So our type here is struct fraction. I know it feels a little uncomfortable to have two different words there for our type, but that's our type, is struct fraction. All right. And we ultimately want to set answers, numerator and denominator to the correct value, right? Well, we already know our denominator will be the two denominators multiplied together, right? So we can go ahead and say answer dot denominator is equal to F1 dot denominator times F2 dot denominator. And then we could say answer dot numerator is equal to, this is where we do the cross multiplication. So we want to say F1 dot numerator times F2 dot denominator plus F2 dot numerator times F1 dot denominator. Make sense? And then ultimately return our answer. So we can test this guy up here. Let's go ahead and get rid of this extra stuff. All right, so we have our fraction F3, fraction F4. We'll say struct fraction answer is equal to, and I called it add fractions structs, and we're going to pass it F3 and pass it F4. And it's going to give us the answer back as a struct. Did we write a thing that knows how to display struct fractions? We didn't, but let's not waste too much time on that. So we'll just output it. We're going to say cout answer.numerator answer.denominator. Oh, I'm missing line 40 expected closing thing before this. So I opened a curly brace. It didn't close a curly
You
brace.
have an extra semicolon.
Got an extra semicolon. We're going to assume
Line 39.
Perfect. Oh, thank you. Actually, we could say I did that on purpose, but I didn't. That was from me copying it in at the end of last class, right? So I'm guessing some of you found that when you were trying to do your homework. So we're going to pretend like I did it on purpose, because that's actually a very interesting common problem where you're wondering why the behavior of your code is behaving Not right. It happens a lot at the end of loops. You throw a semicolon at the end of a for loop, and then you have your curly brace stuff underneath it, and it's not looping, and you don't know why, because you ended the statement up at the top of the for loop, right? You know, your body of your loop does not exist.
Still wouldn't tell you.
No, because it's not illegal code. You have a for loop that does nothing, followed by a block expression for no good reason that syntactically is allowed. Open curly brace, bunch of stuff, closing curly brace. You would never see that in the wild officially, but syntactically it's allowed. That's kind of why beginning programmers start running into issues with having too many curly braces. You know, just when in doubt, add curly braces. Kind of is the thing. It's like what I do with commas when I'm writing something. It's like, well, there could be a pause here, so let's throw a comma in. All right. Then I have my wife look at it, so it's not like I was a 5-year-old writing something. All right. So there is our 6/8 doing that with structs. All right. So now I'm gonna update this just a little bit. Well, first of all, any questions on this one? So we see how it's starting to feel a little cleaner, reads a little bit more like English. We're taking numerators, multiplying by denominators, and it's specifying that. We don't have to understand, well, what's bucket 0 versus bucket 1, all these things. All right, so this feels a little bit more logical, even though we're doing the same thing. Now let's just write a second version of this guy. And somebody tried to protect me against on purpose, including this semicolon this time. Let's see, add fraction structs. Let's call that add fraction structs 2. We're going to write a different version of this. But this guy is not going to return anything. Instead, we're going to update the first fraction to be the answer. Okay, we're going to prove a point first, and then we'll go back and fix it up. So the function is going to return nothing, but our intention is to, in the end, make F1 contain our answer. So we'll go ahead and write this guy. Can actually steal the majority of this code. All right. Now we're just going to overwrite what's in F1 with our answer. So F1 dot numerator is equal to answer dot numerator. F1 dot denominator is equal to answer. Denominator. Okay. So we are updating this guy with these new numbers. Well, I guess I'll just write it again. All right, so we have our struct F3, F4. We're passing in F3, F4. This guy does not need to have an answer that fires out of there because we're actually intending to update F3. So when all is said and done, F3 should be our 6/8 instead of the 1/2 it used to be. All right, so we'll change this guy to output F3's numerator and denominator. And we'll go ahead and run this, and we see that it's still 1/2. Okay. Now, we know that all the logic inside that function should be producing 6/8. We know that if I were to take this line right here, and hold on a second, let me do one thing real quick. All right, same answer, but I actually was calling the wrong function before. So I'm calling my add fraction structs 2, passing it F3 and F4. That guy presumably is updating F1 in here, which is our synonym for F3. We passed in F3. We refer to it as F1 inside the function because that's what the name of our parameter was. We updated it right here. We know that if we were to output F1 in here, it would now be our 6/8. So we see that it definitely was modified. But when we exited, when we were done with add fraction structs 2, F3 had reverted back to its previous value. What does that tell us about structs being passed to functions? I've said it out loud a couple times, but let's read. They're passed by value. Yep. So when you pass a struct to a function natively, you don't use any sort of special pointer syntax or whatever, it goes in as a value, not an address. Whereas if you defined an array and you pass the array into a function without any special pointer syntax or anything like that, its default state is to be passed in by address. So arrays and structs behave differently from a how they are passed perspective. Structs are passed by value in C++. Arrays are passed by address. All our primitive types like ints and chars, they're all passed by value. So structs behave like normal primitive types. Okay, where things get really upside down is strings, and we'll talk about this more on the Java side of things, since Java is really a string-based language, so we're going to be using strings a lot. But string is an object type, which we're about to start talking about. Object types in programming languages almost universally are passed by address by default. So objects in object-oriented languages are passed using the same mentality as arrays are passed. We get a pointer to that object by default. Whereas structs and all of our primitive types are passed by value. We get a copy. So as he pointed out, since F3 is coming in as a copy for F1, when we change it right here, we are modifying the copy, not the original dealie. Now, we can fix that, right? We can, and this really actually repeats, I think, your version of the function when we were dealing with 4 variables, right? You know, we can say, okay, we gotta hack this a little bit. So we need this guy here to be able to have his value permanently modified, which means we cannot pass him in by the default behavior of passing into my value, passing in my copy. So we're going to say, okay, well, this guy's actually now expecting a pointer to a fraction struct. We maybe would do that for both of these, but since we don't have any intention of changing this guy, we don't need to. This will just make it extra confusing. So we're going to pass in a pointer to a struct for the first variable and just the struct itself, a copy of that struct for the second one. So now when we call it right here, we can't pass it an F3 like that. It's going to yell at us, says cannot convert a fraction to a fraction pointer. So how do I pass F3 in correctly if this function is expecting a pointer to a fraction instead of a fraction itself? Put an ampersand there. Ampersand. This says the address of F3. I'm passing in an address. This guy is expecting an address. The error we got before was accurate because the first thing it read in was my prototype up here. So it was holding it to the standards of the prototype, not that I didn't have my implementation correct. All right, so add fraction structs 2 takes in a pointer to a fraction and then a normal fraction. So we'll go ahead and pass in that pointer to the fraction and then a normal fraction passed by value, which means inside here, whenever we're working with F1, we need to say star F1. Usually that's written like that. Put it in parentheses, and I'm purposely doing it this way to show you one evolution in C++. Now remember, when we say star F1, we're saying, give me the value that lives at that address, which is the actual struct. All right. So we are outputting the value here just to prove that it was changed internally. All right. So we pass in the address. We use the value at that address inside here. We change the value at that address. We prove that that change at least has lived locally. When this function ends, we're hoping that F3 has now been permanently changed, and because we updated it at its address. And there is our 6/8 and our 6/8. So does that difference make sense? When we want the value to be changeable, when we're going to change a value inside of a function and we want that change to be felt outside of that function, we have to ask ourselves, how do we want to pass that value in? And then compare that to how does that value get passed in by default? Structs are passed in by value, so we have to ask for a pointer to that dude. Arrays are passed in by address, so we have to ask for just the array, but we usually use pointer syntax. We don't say, give me, an int AR open close brackets. We typically don't call it an int array like that. We just say, give me an integer pointer. So for example, if I have a function, void do something with arrays. So let's say this guy takes in an integer array as a parameter. We typically don't write it like that, even though this would be the example of relying on the fact that arrays by default are passed in by address. That's the default behavior of an array, where structs are passed in by value by default. Usually we would write this as int pointer AR. Give me the address where this array lives. Now, I'm not going to go and implement this guy, but let's just pretend to call it. If we were going to call that do something with arrays thing, what are we going to pass in here? We might say int AR5, something like that. If this guy took in a pointer, which it does, remember up here, we said it takes in an int pointer. Can I call it just like that? Is that the legal way to call it? Line 29? It's expecting an address, right? Am I giving it an address? Is AR an address? Default behavior of an array, it's passed by address. So AR is an address. That's what that dude is. All right. Now, like we learned last class, AR is a local variable of main. So it only stays alive as long as main is alive. But that's okay for us in this case. So we can make changes to it since main is still alive while our function is cooking. It's the other way around. When we created a integer array using the same syntax inside of a function, we saw last time it dies when that function dies. All right. But in this case, if we just focus on these two lines, this is legal code. I'm defining an array. And we had in our slides how arrays are actually working under the hood. This dude right here, memory addresses all over the place, right? So I built an array, do something with arrays, expects me to pass it an integer pointer, the address to an int. Is AR the address to an int? We know it's an address, but is it the address to an int? Because that's what I said it should take, right? As I've defined it right here, does that guy mean integer array definitively? Or could I pass a single int by address? Not knowing what that function is supposed to do, could I say int b is equal to 7 and then pass this guy the address of B. Is that allowed? What's B? B is an int. What's the address of B? A pointer to an int. What's this guy expecting? Pointer to an int, right? So if I want to pass in an integer here, since it expects an integer pointer, I have to say, here's the address where you can find my int. But if I'm going to pass in my array, I just say AR, not the address of that, because AR is an address. It holds an address. So how do we know that this guy is expecting an array instead of a single integer value? Just by looking at it. I haven't implemented it, so you haven't been able to see how I might use it. I haven't provided any comment or anything. If we look at that, how do we know what to pass this function? Because all we see is it saying, hey, give me the address of an int. We've already covered that the address of an int can come in a couple of different flavors. It can come as just an int, giving you the address of it, or it could come as an array. Why is the address that an array holds actually identical to the same thing that an int would hold? The address of an int. What's the value that an array actually holds? When I build this array here, this guy is going to, so we're going to say AR is a memory address, right? What memory address specifically does AR hold? I'm not asking you what the value is, but what does that value mean? It's going to be a memory address, but what does that value mean? What is it actually pointing to? Or here's our so F1, after we allocate some stuff, or we can use this other syntax too, just like this. F1 afterwards holds the value 100. So in our minds, we think of this as being all of that being F1, correct? But that is not all F1. What does F1 actually hold? And this is similar to how real life works. We imagine our house is a collection of rooms, right? And I give somebody the address to my house. That doesn't necessarily give them access to the garage. Just gets them in the vicinity of my house, right? When I build an array, the value stored in that array is the base address of the array. Notice in this example here, I said that this memory was created at memory address 100. I just pretended like I was a very generous operating system giving easy memory address numbers. All right, so F1 holds the value 100, which is the base address where this entire array begins. Remember last time we were talking about like the size of an int or the size of a char? So arrays, the variable that an array holds is the value that, or the value an array holds, an array variable holds, is the value of the very first element in that array. And then we take steps through memory of the appropriate size to get to value at bucket 1, value at bucket 2, value at bucket 3. Make sense? If it's storing ints, we take 4-byte steps. If it's storing chars, we take 1-byte steps. Storing shorts, we take 2-byte steps, so on and so forth. All right. So the type of the array dictates how big our steps are when we move from bucket 0 to bucket 1 to bucket 2 to bucket 3. It does the math for us under the hood, but it's important that we've classified that array, that pointer, as having a type, because that type dictates how big those steps are. We saw last time when we used this syntax right here, malloc does not give us an int pointer as a default output. What is the default output of malloc? Go ahead. Void pointer. What's a void pointer? If you had to give me your rough definition of a void pointer, what would you say? First of all, it has the word pointer in it, right? So in our world, what are pointers? Memory addresses, right? What would a void pointer be?
Doesn't have a type associated.
Doesn't have a type. Now, what I'm about, so the point is that this doesn't seem all that difficult. I mean, you know, you're assimilating a whole bunch of different information as I'm throwing a bunch of things at you, right? Okay, but this concept does not seem all that difficult. I would say probably half of the developers in industry do not know what a void pointer is. They might guess that, oh, it curly points to nothing or something like that. Part of that is because many of them did not learn an older language first. So they don't have an appreciation for how memory actually works. Okay, so as you pointed out, a void pointer is a memory address that does not have a type associated with it, which means it does not have a specified step size that we will take when we walk through memory. So the default size, I actually wonder what the default size would be. I'm not sure if it would default to maybe 1 byte steps or if it would default to size of memory address steps, which maybe would be 48 or 64-bit steps. In either case, it's still consistent with something I've said earlier in the course. Never rely on default values, right? If you want to take integer size steps through memory when you go from bucket 0 to bucket 1 to bucket 2, so on and so forth, tell it it's an integer pointer, not a void pointer. All right. So usually we would do something like int pointer malloc like that. If we're writing this in older languages. If we were writing the same thing in Java, we would say int array f1 is equal to a new int array 4.
Does new int still work in C++?
It does. Yeah. I think we used it last time, right? But the difference is, okay, so last time in class, I said this is the syntax that's the friendliest in C++, and Java takes from this syntax. Obviously, this is what the cool kids would write because it's scary. You're wearing the new cool. Or don't people collect like expensive Jordans and stuff now? But they don't wear them, right? It's like a collector's thing.
Don't want to recall.
I had like the first several Jordans, and you know, we're wearing them outside in the mud and stuff. It's like thousands of dollars. All right. So does that make some sense? How all this stuff is working? So as we start moving towards this idea of going into Java, most of the time what Java does is it takes a lot of those things like this where, hey, it's an array. I know it holds a memory address, but you don't have to play this game of saying, oh, well, I need to make sure I cast it to an integer pointer instead of a void pointer because I'm working with ints here. You will always do that in C++. So whenever I would say in general, whenever you find yourself always writing the same extra couple of characters of code in a language, modern languages probably remove that extra step if you're always writing it that way. So in Java, it automatically knows, oh, you want to take integer size steps. You don't have to give me anything special. Oh, this guy's an array, no problem. You don't have to say it's an int pointer or anything like that. It's an array. It's a pointer. We'll take care of it. All right. Questions about any of that stuff so far? Go ahead.
Between C++ and Java.
There's no difference other than just maybe a couple of quality of life things. Think about like if you start a new video game when it first comes out, like I was a big World of Warcraft player for years. So in the early days of World of Warcraft, if you wanted to do a dungeon or something like that, you would be standing in the center of town over general chat saying, DPS looking for Black Rock Mountain, the group or something like that. Or now they've added all sorts of features where you didn't have to even talk to human beings. You just put yourself in the queue of interested in doing this. Here's my, what kind of character I am, healer, tank, DPS, whatever. And here's my gear score, so you know how good I might be, right? But it's all done in an automated system, and you just hit a couple of buttons, and you just wait till you get not even just invited to a group, you get transported to the dungeon. Even before, once you found the dungeon, you had to travel there. You had to take some of those, some birds. You might have had to take a Zeppelin in World of Warcraft. Any of you WoW players and a former, man, that's so bad that no more do we. I mean, I used to have whole classes of WoW addicts. We would create our own guild and go do like end game content and stuff. Now that's not the cool game anymore. But in any case, over the years, typically when a video game starts getting expansions like that, a lot of them are quality of life things, right? The same stuff is happening. It just took out the 10 minutes you had to spend to get yourself to a location. It just takes you there, right? So I would say, to your point, you asked, so is Java and C++ basically the same thing? Java would be like the fourth expansion if C++ was a video game. The core game is still the same, but they've added some stuff to make your life easier, maybe make you a little bit less error prone, something like that, by removing these different options for doing things. All right. Any more questions about any of this stuff before we start doing a little bit of a transition? All right. So let me just quickly give you the crash course in Java. Typically, when one thing I would encourage you to always commit to memory for the different programming languages that you want to, let's say, claim you're competent in. I think it's an important thing that every language that you claim you're competent in, you should immediately be able to get a simple working program in that language, which effectively means memorize the structure of a Hello World program. So typically this guy writes it for us, but if I, let's just start a new project. Let me save this. Am I not logged in? Who am I logged in now? Hold on. Let me take some of my error stuff out of there. Do something with arrays is gone. I just want to get the solution to the homework out of here or in here so I can put it up on Slack. All right, let's get us there. All right, I think we're reasonably good there. Structs in C++ fraction example. All right, so there's the code that we've written so far today. So now what I'm going to do is I'm going to start a new project. And the very first thing we're going to do is we're going to select a different language as our starting point. It's one of the reasons I like this tool. It's not always the best editor and stuff, but man, it's good one-stop shop for being able to explore a whole bunch of different languages. So we're going to choose Java. Now, before I click that, notice by default, it's given us a Hello World program here without us selecting anything. Can anybody tell me what language this program is written in? Good. It's C. Well, doesn't it basically look the same as our C++ program? How do you know this is C? The way it's printing it out, printf, we know is a C function. Well, I say we know. Historically, if you had studied these languages, you would be able to look at this immediately and say, oh, this guy uses standard IO, standard input output. That's old school C. So it's using printf. In fact, frankly, printf is better than cout in pretty much every single way. Because printf allows you to, for instance, let's say I had like and this, what I'm about to show you, does translate into most new languages. Most new languages have a version of this type of thing that you'll find friendly. Because you've probably seen up to this point, like for instance, when we go to print out like a fraction, we've made our fractions look pretty. We have to do here's the numerator, then a couple of the arrow things, and here's the slash, and then a couple of the arrow things, and here's the um, uh, denominator or whatever. It starts getting tedious as you're gluing a whole bunch of stuff together. Printf lets you do something like, so if I say int a equals 5 and I want to say hello world followed by a, we are used to doing something like that, right? Actually, we would have to do like that to make it work. That's how you would write it in C. You just put a placeholder in here. %D is for a decimal value. Newer versions of C do allow you to say %I for integer, but the original is %D for a decimal value. That's the placeholder for anything decimal. %S is typically a string, that kind of stuff. %C is a char. So this is going to say whatever this value is, inserted for your first placeholder. If you have a second placeholder, well, I could always put A in there again, but I could also do something like int B is equal to 7. And since I have two different placeholders here, I could have two different values that I loop in. So it allows you to write your entire string as a single string with just a couple of placeholders in there, and then lets you insert the placeholders there at the very end, and it'll ultimately do all that concatenation stuff for you. I personally think that's better than cout. Cout uses a different underlying technology called streams, which are more efficient in terms of the memory they use. Most modern languages under the hood use streams, but give you some tools to be able to work like this. So you get the kind of the best of both worlds. Although the default way we do in Java, you'll see it here in a second, is actually not to use the stream version. Well, it is using the stream version, but not to use the thing that allows us to conveniently insert things like this. We're typically using system.out.println, which is, from your mentality, the same thing as cout. If you want to glue multiple values together, you have to put plus signs between them to concatenate them. But we'll look here pretty soon that in the system class, there is something called system.out.printf, which you'll find behaves very much like the C version of printf. Huh?
How do you?
Oh. Printf, if you want to end line, you got to do a \n in there. If you were in normal Java, the default, and I'll show it here in a second, system.out.println, ln is kick it down a line. System.out.print doesn't kick it down a line. So you actually do it based on the function you call. But \n will work in any language. That's the line feed thing. So it used to be \r \n. \r \n is carriage return line feed. But most terminals now treat \n as both. It just does the whole ninja move. All right. So point here is that anytime you learn a new language, I would say that it's important that you memorize a working hello world program in that language, or a working simple program in that language. We just call hello world like your basic program. If you know the structure of that language, you can get it working instantly, then the rest of it just becomes your programming skill. You just have to give yourself the framework. All right, so if I switch this to Java, okay, because I had made some changes, notice it didn't fix it for me, right? I'll go ahead and write it, and this is what it would have given us. All right. So first of all, I've said it out loud a couple of times that we're dealing with an object-oriented language. The whole reason we're transitioning over to Java now is to start introducing writing our own objects, which you can do in C++. C++ supports objects. What we're going to be doing here is very, very, very similar to what we were doing in C++. The one thing that we are missing, and I'll just throw it out there as trivia knowledge for you right now. So let me just write a little C++ for a second, just down here. I had my, int array AR, and then we had an example where I was outputting it, and I said something like, actually, let's not operate off of AR. Let's pretend like we're a fraction. So we had our fraction numerator like this when we were having to resolve or the point or the value at this address. Typically in C++, you would actually write this slightly different. This works, but we would say this is a little bit tedious to write with all the parentheses and stuff. Anybody know the alternative on how to write this in C++? There's a shorthand or something like that. It's F1 arrow numerator. This guy right here does the identical thing to that guy right there. So these are typically called double pointers. These are pointers to pointers, memory addresses to memory addresses. So you can use that arrow to do it. If we were to get into objects in C++, classes are our structure type for objects. So we would upgrade from structs to classes. And what does a class give us that a struct doesn't? Let me actually get this in the notes. Anybody know what a class gets us that a struct does not? I've either said it or kind of alluded to it, but if you have the previous knowledge from it. Let's start off with this. I've mentioned today, what is something that we might want that structs don't have? Structs allow us to store a whole bunch of name value pairs, but what will they not allow us to do? It's called a significant hack. They don't allow us to hold functions. So for instance, I think I mentioned earlier today, what if we wanted fractions to be able to reduce themselves? Where I can say F1, reduce yourself. And then internally the magic happens. And then the next time out, I go to print out that fraction, it now is magically reduced internally. Okay. Structs do not allow us to embed functions within them. Before object-orientedness was before it came out when we were dealing with old school C, there are some ways of creating kind of a pointer to a unnamed function that sort of kind of allowed you to pull it off, at least organizationally, but it wasn't good coding practice. It was just kind of like, this is the only way we can make this work. So most of our evolutions in languages come from us finally hitting a wall or running into an inconvenience like that. All right. So in any case, what does a class get us that structs do not? The ability to embed functions into the class, not just variables. So not just name value pairs, or here, let's call that, not just name value pairs. All right. Name value pairs being like numerator is this, denominator is this, name value. All right. So with structs, we have the ability to store a bunch of name value pairs, just like I mentioned, dictionaries in Python and a zillion other languages. Dictionaries existed before Python. But classes give us one more step. They also allow us to put functions inside of there. Make sense? Now, I'll talk about this again. I've said it a couple times. I'm going to keep saying it because it's an important aspect of Java. It's important. I mentioned that my background is language theory. So creating programming languages, writing programming languages. So typically when I'm working with any language, I try to look at it through the lens of the person who wrote it, people who wrote it, and see if I agree with their decision making or were they being stupid. In this case, Java was being stupid. It gets the job done. It's not a deal breaker thing, but Java removed structs. Structs do not exist in the Java programming language because they say, oh, well, you can just use a class to accomplish the same thing as a struct. Just don't put functions in there. A class with just name value pairs and 0 functions is the same as a struct. And it mostly is, with one exception. That's an important exception in terms of how you use it, especially if you're a programmer coming from different languages. We talked earlier today that structs by default are passed by value. Classes by default are passed by address. So even if you use a class to fake a struct and just not put functions in there, it still behaves differently by default. It still gets passed by address instead of passed by value, which means you need to always protect your objects from change because those changes will be permanently felt outside of the function. Especially when you consider in Java, we lose the special syntax for pointers. We no longer have asterisks and ampersands to dictate whether we mean the value at or the address at. Java just says, hey, it's our way or the highway, and our way is usually right. Java usually makes the right call for you. In fact, almost always it makes the right call for you. But every now and then when you want to do something kind of funky, probably not something you would do in your normal day-to-day work, but maybe something you're trying to accomplish a little bit against the grain, modify an operating system, hack a video game, whatever it is. Having more control over the memory that the program is running in can be beneficial. Java takes that power away from you, and it probably makes mediocre programmers look better than they are because it prevents them from making some of those mistakes that I think are an important part of becoming a good programmer. Kind of has like training wheels, all right, which is why we start with an older language. All right, so a class gets us the struct, gets us that a struct does not. It allows us to put functions in there, not just name value pairs. All right, so our hello world program in Java. First rule. Let me just give a slide that gives the definition of a class real quick. Class keyword is how we define an object in most object-oriented languages. Object-oriented languages, OOL. You'll sometimes see it written that way. So we use this class data type that behaves, it kind of looks like a structure, right? We say class, opening curly brace, a bunch of stuff, closing curly brace, just no semicolon at the end of it. A classes contain 0 or more of the following components: fields, constructors, methods. Okay. Every single class will have some combination of 0 or more of these 3 things. So let's talk about what each of these 3 things are. This is kind of giving object-oriented naming conventions to things we're already kind of familiar with. A field is a name value pair, i.e. variables owned by this class or instances of this class. We'll talk about the difference when we talk about static versus non-static stuff soonish. Okay, so effectively, what Java would say is a class with only fields in it is the same thing as a struct, where I would say it's almost the same thing as a struct, outside of that pass by value versus pass by address thing. All right. So that's what the fields are. The variables, the name value pairs that are part of it. Constructors. These are specialized functions that do the initialization for an object as an instance of it is being created. And these things will all make sense as we start seeing examples, but let's just get the words out there first. All right. So constructors, kind of like methods, but they actually don't have a return type because they always return memory addresses. A constructor is always called using that new keyword that we've mentioned a few times. And we'll see this a zillion times. So don't worry if you're not fully connecting the dots here yet. Methods, fancy name for functions. Object-oriented languages call their functions methods. In older programming languages, I think I mentioned this when we first talked about functions, they used to be just called subroutines. Then we had the idea of functions and procedures, where functions were functions that returned a value, where procedures were functions that did not return a value. For now, we just call them all functions, and we have a return type of void if it's not supposed to return a value. Now they just rename the idea of a function to be called a method, just so that's the naming convention for object-oriented functions. They still have a return type, they still have a name, they still have parameters. It's the same thing. All right, fancy name for functions. That's what classes hold. As you remember back first couple of weeks of class when we were talking about object-oriented languages versus procedural languages, and I had the telephone example again, and I mentioned that, you know, the procedural version of a telephone, there's this big pile of wires where we see everything exposed and all that stuff, where the object-oriented version of a telephone looks like a telephone and has all of the stuff packed inside of it. Classes are organizational tools, pieces of Tupperware, or however you want to think about it. It is a single pod, and what we put inside there is all of those wires that go inside of that telephone. In terms of all of the name value pairs, we need to keep track of all the fields. In terms of all the ways of generating a new telephone, most telephones have a basic common set of features, but then certain telephones have extra. You know, some used to have built-in answering machines and stuff like that. It is pretty funny when we're starting to talk about telephones as if it's ancient history. When I was a kid, you had to build up the calluses because you had the rotary and you hit it every single time. You build up the calluses in your finger. You couldn't get any more than 3 feet from the phone because it had the cord. Then now you see those in a museum, right? I'm not that old. I mean, I'm older than all of you, but I mean, I'm 47. I think my dad used Campbell's soup cans and strings. All right. So don't get overwhelmed with the idea of a class. Object-oriented languages are not like major gear shifts in programming paradigm. They're just saying, hey, you were already writing code that was needing the idea of name value pairs. So we kind of gave you structs, and it was like, well, you know, I'd really like some of these guys to be able to do stuff by name, and I want to be able to throw functions in there. And they say, oh, no problem. We'll just create a whole new paradigm of programming languages, this idea of an object-oriented language that only adds that. Effectively, that's it. That's the difference between an object-oriented language and a procedural language, an organizational tool. Most object-oriented languages are just newer languages. So they may have several of those quality of life things added to it, but they're not necessarily object oriented in nature. The way the language is built that we'll talk about is kind of an upgraded way of the language being built under the hood. But from the programmer's perspective, when you're actually leveraging this language, you're wielding it, it's just one more organizational tool. You didn't have classes in C. It capped out at structs. So C++ came out, which gave you classes, but it didn't add a whole lot of quality of life stuff. Then Java and C# came out. Well, Java came out first. C# was the result of a lawsuit, same language, whatever. But that comes out. What did that do? That kept the object-orientedness of C++ and added quality of life stuff. It runs in a virtual machine and some other protective stuff, but that's all the same crap. All right. So going back to the example here. So in Java, all programs live inside of a class. Now, you can name your class whatever you want. You are limited from when you first start your program in Java on online GDB because it generates the file for you. It names the file main.java. I'm not sure if it even let us rename that, will it? Oh, it does. So I'm going to call this guy driver just to create a separation. And let me connect the dots here a little bit. How many of you, if you buy a new graphics card and you have to install drivers for your graphics card, what does that mean? What does it mean to install drivers on your computer for a piece of hardware you just bought?
You install like the necessary firmware for it to be compatible with whatever you're using.
Yep. So firmware is similar, but firmware is on the actual device. Driver typically is the software, but to her point, it might be the software that knows how to talk to the firmware. All right. So when you get this new graphics card and you first put it in your computer, you just spent $1,000 on this high end, blah, 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 can run Microsoft Word at 4 zillion frames per second. Always brag about your frames per second with your graphics cards to your gaming buddies by telling them what kind of frame rate you get for word processors. It'll be off the charts. Okay. But you have a piece of software that goes on that Windows needs or Mac OS needs, whatever it is, that knows how to take advantage of all the special features of that $1,000 graphics card. When you first plug it into your computer, it treats it as a standard Super VGA, SVGA graphics card. Sometimes even less, sometimes just a VGA, which is like minimum viable. I can put colors on the screen, right? And like, I spent $1,000 on this. I'm running at 640 by 480 resolution. Okay, this is like Lippmann size font. Those software drivers, that's the program that knows how to drive that piece of hardware and take advantage of all of its abilities. So remember, I've mentioned that all programs begin and end with main. I will commonly name, and so in Java, pretty quickly here, since we're going to start working with objects, well, very quickly here, we will almost always have multiple files as part of our program. So in our example that we're about to get into, we might have one file that runs our program, but we might have another file that's called class fraction, right? Fraction.java would have a class in it called fraction that maybe keeps track of two fields, numerator, denominator, and maybe has a constructor that you can pass a numerator and denominator to. It'll set those fields equal to those values, initializing it. And then maybe it has two functions, one that can display a fraction and one that can reduce a fraction. Maybe we also have the ability to add a fraction. So a fraction could add itself to another fraction. And we'll write all this on Tuesday. But in any case, I will commonly name my one file that has main in it. You can only have one in a Java project. You can only have one file that's the conductor that's running the whole show. I will commonly call that driver because it's driving the program. You can name it elephant, doesn't matter. But in Java, the class name has to match the file name identically, including case sensitivity. So if I'm going to have a file named driver.java, it's going to have a class in it called driver. Make sense? That's why I had to rename the thing. I feel like that's kind of new. I kind of remember that being a sticking point previously, that I couldn't rename that first file, the main.java. And I don't like it named main in this case because it creates a confusion between what we already think of as the main method, and then all of a sudden you have this another word main sitting here with a capital M, and they have nothing to do with each other. So I like it just to be a different word. All right. So in C++, we've seen main before. We've talked about main several times. In C++, if we were to write out our whole main, we typically have int main, int argc, char pointer argv, which is the same thing as a character array of strings, or an array of strings is what this is. So this points to an array of characters, where each array of character pointers, where each character pointer points to the beginning of a string. So this is the expanded main method for main function in C++. Notice here that forget about these first two. We will be talking about these relatively quickly. Okay, but but they are required. And we'll explain why then. But main returns nothing in Java, whereas main returned an int in C++. Why did C++ have it return an int? And keep in mind the vintage of these languages. When C++ first came out, most of our programs were command line programs that you would run, or you have one program call another program and things like that. So that return value was kind of like an error code to know whether the program that just ran okay. All right. Now, most of our stuff is object-oriented, or I'm sorry, most of our stuff is graphical user interface stuff, even though we're not going to get into that till we get into the game programming stuff. But on top of that, most of our modern languages like Java have alternative ways of dealing with error codes through exception handling and stuff like that. That's why main in Java returns void instead of an int. And then lastly, and I'll end class with this last step, main takes in an array of strings as a parameter, just like C++ took in an array of strings. This is for command line arguments, which used to be a thing, still is sometimes a thing when you're a back-end programmer or something. But this is only if you're running something from the command line or whatever. So it took C++ took in an array of strings, but also had to take in how many strings are in that array, because arrays in C++ don't know their length. They can't report their length. In Java, arrays can. So really, you're seeing C++ and Java, what main looks like. And after we broke it down, they're the same thing. Make sense? All right, I'll just run this guy real quick. So there's our working hello world program in Java. All right. So I'd encourage all of you to be able to memorize something like this at some point. Maybe we'll have an online quiz or something like that has you write this by hand. Being able to write a working hello world program instantly will make your life easier, because you won't have to go and look up a sample program and things like that, and you can just build from there. All right. Questions, comments, concerns, bribes?
Oh, do we have homework?
Yeah,
No homework. I didn't quite get there, but we'll have homework on Tuesday. So maybe over the weekend, memorize this Hello World program thing.
yeah. I just got like a quick little question.
Sure, go ahead.
Uh, so like you said C++ to Java wasn't like all that different, right?
Correct.
Right. So is Java the JavaScript, is that like about the
They're
same difference?
unrelated. Java and JavaScript are not related at all. The name is the only thing
Oh,
they have in common.
oh, okay. All right, thanks.
JavaScript predates Java by a lot. And Java's a
Oh,
different kind of language. Java's object-oriented, strongly typed. JavaScript's it is object-oriented, but it's a loosely typed language.
oh, okay. All right, thank you.
Yep. Let me get this.